not bring myself to study that much. I don't know why.
Like, you're still gonna have to take the whole one eventually, and you can schedule for that one, and like, you don't have to wait.
What do you mean you have to wait?
Because they may like to cancel one, but they can still take a different one in that off period.
If he starts seeing
Okay. Rachel, I don't see.
on her way.
Okay.
I
Here.
don't know if she drives, is she a teacher?
Yeah.
I think I know the All right. Rachel. Okay.
By the process, this is what Hannah's telling me. Thanks, Hannah.
Okay, any questions for me?
How was your weekend?
Very busy, very busy. Working a lot. Had to buy another car. Used one. I didn't have to, but this one, oh, what is it? Why did I get this? This one takes too much gas. It's 19 miles per gallon. I live an hour away from here, so every other day. Oh, well. Anyway, so I
What kind
got
of car did
more
you
fuel
get?
efficient. Kind I get?
Yeah.
Camry hybrid. I don't really care, as long as it was cheap and it was getting me the gas mileage.
You're telling me.
Okay, let's see here now. We were talking about the 8 math practices last time, right? I don't think we got anywhere with time, correct?
No, correct.
So that's what we're going to do today. All right, so the 8 math practices, you're to read the second 2. Okay, and I've been relating them to these fundamental concepts to teach math here. Again, remember those 8 math practices are drawn from these ideas. Ohio and really the Common Core has taken these ideas and just turned them into something and put them right in the standards, so you're going to see them in every grade of the math standards. I'm still kind of rushing because I was trying to get over here and get everything set up. Okay, let's see. The third math standard, students construct viable arguments and critique the reasoning of others. Let's think about that here for a second. If I asked you to divide 8 divided by 3, okay? Think of all the remainders you can get dividing 8 by any number. What are all our possible remainders?
You said divide by 3 or divide by anything?
By anything.
2.
How would you get 2?
Divide by 3. No,
Okay.
that would be 1.
Divide by 3, we get the remainder of 2.
No,
Is that right?
no, it would be 1, sorry. Because, no,
No,
I
you're
can't
right.
math.
Okay, another top possible remainder?
By 8 by any number, you could get a 0 remainder. If you divide 8 by 4 or 2 or.
Okay, so we get a 2, a 0. Okay, what else?
Divide by 5, you get 3.
Divide by 5, you get a 3.
Yeah.
Okay. Another remainder?
Well, 1,
1, how do I get that?
7.
Divide by 7, okay.
Are you doing negatives? You getting fancy?
I don't want to go into the negatives. I guess that's it, right?
I think so, yeah.
Okay. What about if I were going to divide 7 possible remainders?
Well, 1,
1, okay.
2,
2,
3,
3, any other number? I don't think we can we? Okay, how about divide the number 9? Get 0.
One.
Get 1. How did I get that?
Never mind, just adding things again. I was like 9, 8, was this one left over? But no.
9 divided by 8, yeah. And 1 remaining. Right? 8 goes into 9 once with 1 remainder. We get 2.
It would be 7.
By 7, so you get 2.
We're just going right down the line like 6 now, so 6.
6, remainder 3.
3.
5. Any other remainders?
Well, the 4.
If we put 4 in there, we have a remainder of 1. It's easy to think that
Say that again.
if we put in 4, 4 would go into 9 twice.
Ah, yeah, that's right.
Okay?
And that would be it then.
That would be it. Okay? So what if somebody said to you, divide 6, what if they said you could get a remainder of 7? Now remember, we're in 2nd grade here. We aren't going into any fancy rational numbers or anything like that. I mean, irrational numbers, imaginary numbers. What if a 2nd grader said, I think I can divide into 6 and get the remainder of 7? What would you say? Yes.
When I first asked their process, and why they're thinking what they're thinking,
Okay.
and then maybe pose a question and like note that 7 is larger than 6. And
Okay.
remind them that it, like, people were dividing, so what does divide mean?
Okay.
And like show them like how it's breaking a number down. And then ask them again if 7 makes sense.
Okay.
And then see if we can grab their thinking.
Yeah, very good. I mean, I actually wasn't thinking that you would use teacher mode and start doing this, but you're doing exactly, yeah, what you should do as a teacher. Yeah, but why can you, I mean, that's actually very good. Why can't it be 7? I think you already said it.
This is all looking smaller.
Okay, because, yeah, so all the remainders, what do they all have in common? Yes.
They're all smaller than the number that they're dividing by.
Okay, they're all smaller than the number you're dividing into, so to speak. All right, so we know that. Okay, and why do they have to be smaller? What if I said, I don't believe that? Which I do, by the way, I believe it, but why, what would you say? Yes?
I guess I would tell somebody if they're bigger, then it could go in again. It might be able to be duplicated.
Okay, all right, so it could divide it again, sort of like what we did with 9 divided by 4, right? And you just took it in once, and there was 5 left over, but it could still have something else pull from that. Okay, now this really isn't that important. Okay, this content here. What I'm trying to get you to do is construct a viable argument and critique the reasoning of others. And that's what you want your students to do. Okay, remember, students are doing all this, by the way, it's not the teacher. Okay, so like Lauren, when you said, okay, I'd ask them what their thought process is. The next thing you'd want to do is, once it's shared with the class, you'd want to say, okay, now, what do you think, Shannon? What do you think, Kayla? Or you say, what does anybody think about that? Lauren says this. You're trying to get them to critique her reason if it's wrong. So in my case, my reasoning is wrong, you know, let's just say I said this as an answer, and then the best thing for me to do as a teacher would be to get the students to help me in this case. Okay, critiquing the reasoning of others, that causes students to really understand some of this stuff, again, over here, like the concept, what it is that we're doing. And Shannon, like you said, first off, the remainder has to be smaller than the number you're dividing it into, okay? Because you can't have more left over than you began with. So I just created a reason right now, okay? That's what I want the students to say to each other. Okay, and so I have to go back to the concept of what it means to divide. If I really don't know what it means to divide, I can't do that. Okay? I also could do this thing here, like explore, find a pattern, which is what I was doing up here. I'm looking at finding a pattern up here. Okay? And one of the patterns is that the remainder is always smaller than the original number. Okay, that's a pattern that came up there. Okay, you also see that it is interesting, and I don't have an answer for this, but it's always less than half. Do you notice what I'm trying to say? So 9 divided by 2 is 4.5, so the next whole number is 4. 7 divided by 2 is 3.5, and so there's 3. 8 divided by 2 is 4, so the next one is 3. Now there's a pattern somewhere in there, and someone in mathematics would have some kind of reason for that, okay? But that's what I'm starting to see here. So now I can start to, you know, and somehow I can't figure out why right now, just talking to you, but that'd be the kind of thing like I'd throw out to maybe a 10th grade class or something, to say, okay, why is it like that? And see if they can come up with a thing for that. Although that's not critiquing the reasoning of others, they're constructing viable arguments in that case. Tony, you look like you're going to say
So
something.
you would ask them, like, you can see right here, there's a pattern 0, 1, 2, 3.
Yeah.
It doesn't go to 4 on the other ones evidently, so that's what we would have kids look and see, like, you're just asking them, like, inquiring questions, like, well, how come it doesn't go to 4 if 9 goes to 4? You
Yeah.
want them to just, like, give you why they think, even if it's not, like, it almost seems not relevant, but maybe it is.
Yeah, I mean, yeah, because this content isn't relevant for even for middle school, it's not relevant. But I'm just using that as an example, trying to get you involved, you know, to think about this
Okay.
too. But yeah, that's exactly what I would want to do is, and here I am doing that explore finding patterns, and Tony, you've seen one already. 0, 1, 2, 3, 0, 1, 2, 3, looks like 0, 1, 2, 3 are all in there. Okay, then if I would further explore, like with 6, I'm not going to get 3. I'm going to get 0, 1, and 2. Is that right? Because to get a remainder of 3, I have to divide this by 3, and 3 is left over, so I can divide it by 3 again. Does that make sense?
Mm-hmm.
So for some reason, it's in the middle mark. This, again, this math isn't important, but this kind of does give us this idea of critiquing the reasoning of others. I was just trying to use something that's more college level than elementary school level. Okay? So that's one of the things that, and you can kind of see where it's being drawn out. If you don't understand the concept, then you're very happy with the answer. If someone says 7, you say, oh, okay, I didn't know that was 7. Okay? And we do that a lot in math because we will, for example, if we don't really understand the context, this is a very famous puzzle. There's 25 students going on a field trip. Each van can carry 10 students. How many vans do you need? And a lot of students, most of them will say 2.5. Okay, so 2 vans give you 20, then the half gives you the 5, which doesn't make any sense. You know, how do you have half a van? Makes sense? But that's where they come up. And so that's a very famous example of students really not understanding the context. They get so used to doing the skill of dividing, so they'll divide it and they'll get 2, or they'll say 2 vans, remainder, 5. They'll say something like that. They aren't considering the context. And that's what happens when we're teaching skills-based, just learning how to divide with the remainder. If we just keep doing that over and over again, and we just throw in a few word problems, that's where that becomes unlinked. Make sense? Okay, so in this case, like with that, for example, if someone said 2, remainder of 5, I would say, okay, what does that mean, 2, remainder of 5? What do you think it means? You know, do you agree with that? Why not? And then again, when they start to say, well, I don't agree because you can't have half of that, or whatever it is, see, they're starting to critique the reasoning of the others, or they're building an argument, they're constructing a viable argument. You can't have half of that. Okay, that's what you want to do. Again, the students are doing all this stuff here and doing all that stuff there on the left board. They're the ones that are involved in it, except that bottom one where you're facilitating the questions, which is more exactly what you were doing. Okay? Okay, so a big example just to kind of get through that. Let's see if we can do a little bit better with this one, a little faster. Okay, students model with math. This has kind of 2 directions for it. Either you can take a situation like this classroom, if I count up everyone, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I'm 12, I could represent all of us by the number 12. I'm modeling it with the number 12. Okay? So I took real life things and I'm modeling it mathematically. All right? Or vice versa, I can take some situation like 3 plus 4 and ask the students, what does that mean? Can you show me with the blocks? Can you model 3 plus 4 with blocks? And they take 3 blocks and 4 blocks. You see how I'm translating? That's one of the things, one of the downfalls with teaching in a skills-based thing is that we don't make those connections, don't help our students to see those connections. And so they're very good at the skill, they know what 3 plus 4 is, but they don't know what it means. Now, usually they do know what addition means, but it's when they start to get a little bit older, late 2nd, 3rd grade, they start to lose those connections. And then that's when the math anxiety starts to increase, because now they don't really understand what they're doing. I think I did the limit in the middle school class, is that right? I think I did that limit. And that'd be something where, again, I could okay, so I could show you how to do this problem, and when you know, it may look very strange to you, and think about, you know, a 2nd, 3rd, 4th grader math. A lot of these symbols look very strange to them. Basically, to solve this problem, you put whatever this x goes to 1, you just put that number where you see x, so 12 times 1 is 12, and that's the answer. So if I'd ask you, what's the answer there? 12 again, right? Okay, so now you can do limits. All right, so now you understand the concept, what it looks like concretely. You can, let's see, you can put it into context, right? Of course you can't, because you learned it out of context. Does that make sense? All right, now if I were to put it into context, I could have said like this first one, and this isn't the greatest example, but that the most people we can have in this class is 12. That's the limit, that's the upper limit. All right, and so that's what that thing is saying right there. The limit for one class is 12. X is 1, one class is 12, okay? But we don't always hit 12, okay? Like we began today with 11, okay? And then the 12th one came in. So there's a limit, we won't go over 12. Make sense? That's what a limit really is. It's, you know, we know the term, the word limit, that's what this really is. Okay, so by me giving this to you just before I told you, you know, what it meant, you really couldn't model that with math. In other words, if I had to give you a bunch of word problems, you would have said, well, I know it's got something to do with that thing on the board, but I don't know what this means. That modeling with math is exactly what we're talking about, the word problems, that's what we're talking about here. Can I take a situation, a bunch of words, a physical situation, and turn it into something mathematical? Then I can model it with math. Like I said, we have 12 people in here. I could model this desk with math. I could make a drawing of it with dimensions on it. Now it's a geometric mathematical representation of this. This is a mathematical representation, or you can think of it as a mathematical or a representation, let's put it that way, of you know, the clock, basically the clock. Equations are mathematical representations. Okay, so they're representing something that's going on. Maybe 1, 2, 3 things are varying. and they're just measuring these things, and they're seeing how they're doing it. Like, for example, your car insurance is based upon some kind of mathematical equation. You know, there's a variable for how many accidents you've had, how many major accidents, how many, you know, minor violations you've had. Somewhere there's a variable in there, they'll just type it in, you know, you've had 2, they put it right in there. They talk about the year of the car, the make of the car, and that gets put into this thing. And then they put all these variables in, and out comes how much you have to pay. Okay? They represent the situation with an equation. They model it. So they go from the real world, what kind of car do you have? You know, they give all this information from you. They put it in, they represent it with numbers, equations, and then they come out and say, here's how much it's going to cost you. Okay? Because believe it or not, they do not sit down and say, okay, for a 25-year-old female with no tickets driving this car of this model type, you know, you have SE and LE and all this, you know, it's going to cost this much, and they put it down. And they say, now, if the same female has 1 parking ticket, because this and this, oh, it costs this. Now, if one has 2 parking tickets, you see how that, they don't have it. They have an equation that represents, they're modeling with math your situation. Okay? Okay, so read the next 2 for Wednesday. Now, modeling with math, before we get off of that, that is a big part of what you're going to see in here. It's a big part of early childhood education, because when you begin in the concrete, physical items, or a picture of something, and you go to this abstract, remember abstract are just numbers and symbols, plus, minus, and so on. That's what abstract is. Okay? You're modeling that physical situation with those numbers and symbols. You're modeling that math. Okay? And by doing it, you're understanding, you're in context, because if you have a situation with concrete things, that is a context. Okay, the numbers that you turn them into are out of context. Okay, you understand the concept, obviously, you have the thing in front of you. They can get, just to show how powerful this way of teaching is, second graders with manipulatives can solve addition, decimal addition problems actually very quickly. If they model the decimals with these, they can solve decimal addition. Okay? They can add fractions with unlike denominators, with fractional pieces. Okay? In the concrete, they can do it. So we know if they can do it at second grade, it's not the math that's hard. The hard thing is that we abstract it, and the students never get to see those concrete things. So then we go right to the equations or the rules, and we don't show them any of this other stuff, and we say, here's the rule, you have to do this. And then, if you think about fractions, they reteach it almost every single year that you're in school. Okay, at the beginning of this year, I'm sure there was a 9th or 10th grade algebra class that we could just go to down the road, where they said the first day or the second day they were talking about fractions, adding and multiplying fractions, adding and multiplying decimals. Okay? Because they're a bunch of rules. They don't really know what those mean. Okay? Whereas what you're trying to do is you're trying to say, okay, you can figure this out. If you can't remember, if you add or multiply or whatever it is, if you know what it means, you can figure it out. Okay? Same thing if I said 3 plus 5, what's 3 plus 5? And I can zap out of your minds the answer 8. You'd say, oh, 3 plus 5, that's easy. I don't know. But you could model it with math. You say, okay, 3 fingers, 5 fingers, you just count, that's 8. Because you know what that means. Make sense? Okay. Let's see where we're at. I think we're ready to start looking at the clock. This is called an analog clock versus a digital one, which is the analog, the digital. The digital is what you see at the bottom. down here, 1047, that's a digital, okay, so it's an analog clock. This analog clock that gives teachers fits because students, a significant number of students just don't get it. Okay? I was just talking with someone who teaches in a Plain local district, and she said they don't even teach this anymore, which, I mean, I'm for teaching this, I'm definitely for teaching because too many places still use this. I'm always wondering, when are they gonna stop teaching it and just say, just use a digital? I don't think that this is a good time to be doing something like that. Kind of give you an idea, and I'm gonna try and pull this up. This gives you an overview. For where the grade you have to teach time, like you see, we'll just kind of read. I think it's self-explanatory. It helps you to understand. I'm gonna pull up here. Okay, so time, one of the things that I remember when I'm looking through the standards, I'm trying to figure out, when I was first looking at this, years ago, I kept looking for, well, where is time in the standards? I couldn't find it. It's under measurement. You're measuring time. So I think a measurement, a ruler or something like that, or weight. In this case, you're also measuring the passage of time, okay? So that's what this is. That kind of gives you an explanation of the standards. There will be a link, I don't have it yet today, but there will be a link in your documents to your house standards. You probably have seen these, maybe you've even used your house standards before, especially for math. If you do, there's the 8 math practices that you're reading for me. Okay, so they talk about it here. I don't like the way they talk about it. They seem to be talking about it like they're scholars, like that's who's reading this. Okay, so that's why I rewrote the thing there. And then you're going through this, and then you come down here, like for example, every grade level kindergarten overview, there's the 8 math practices. They're saying this is how you should be teaching this information over here. This is what you're teaching over here. So if you're looking down here, I'm going to go to first grade. You have to look under measurement. Okay, and then somewhere under measurement is, there it is, work with time and money, and that one should be on your sheet. 1.MD.3. Okay? So we have a general idea for what's supposed to be mastered. Now, let's be careful about this. What's supposed to be mastered? It's saying in grade 1, they should be able to tell and write time in hours and half hours using analog and digital clocks, which makes me wonder how any district is ignoring that, because the analog is right in there. It's part of the standards. Anyway, so they're supposed to write time, okay, first grade. It's to be mastered there. You would be teaching it in kindergarten though. Okay? So it's okay to use that standard if you're in a kindergarten class and you're saying, okay, I'm introducing time today. They just aren't going to master it today, but I'm introducing the clock to them, and you will introduce it to them in kindergarten. Okay? Let's take a look at this clock. Want to take a look at it with a partner? I'd like to think about, why is that so difficult? What makes it so difficult? Because it is. I think there are many students in 4th and 5th grade that still cannot read that clock. Okay, so we're going to talk for a few minutes. Some reasons.
Yeah.
Does that make sense?
And if you don't do fraction, you almost have to do fractions and components with that, like. That kind of stuff.
Okay, compare what you were thinking to this little vignette. Let's see if it gives you any additional ideas that we'll talk about.
The video I was gonna send to you,
Oh.
finally uploaded onto my,
Oh, that's okay.
it took like 35 minutes for it to upload. I have to make sure I send it to you.
Okay, what are some of the reasons, or what are some of the attributes or characteristics that make this so difficult? Lauren?
So we started by saying it's like a double meaning to some of the numbers on the clock, like
Okay.
the 3 could be 3 when it's 3 o'clock, or the 3 could mean 15 if you're talking about minutes.
Okay, so we've got one thing, the scale. There's actually two scales. You use the same numbers. They call that a scale. Okay, but they're interpreted differently. Each number means two different things. Tony?
Yeah, we were saying the same thing too, and it's like when the kids will say, well, you know, the little hand and the big hand, one is for the hours, one is for the minutes. Well, how come the little hand doesn't change, the two doesn't change to something else when that's on it, probably the big hand does, and then you answer with just because that's what it says. Like, I don't know, what do you,
Yeah.
what do you tell someone when they ask you that?
Yeah, exactly. More reasons? Lauren?
The fact that it doesn't really depend, I guess sometimes confusing, like that can stop kids in their tracks or really like, why does it go 12, not 10, because other people want these like 10s.
Yeah, we're a base 10 system, except this is not. Grace?
I think that like the lingo that we use with kids really messes them up.
The what?
Like the lingo that we use, like we use it like quartile, whatever, where quarter isn't actually like 25, which doesn't make sense either.
Yeah.
But like using that, it kind of like confuses kids too.
Okay, definitely our language, quarter means something with money, it means something different here. Lauren?
So even like right now, the time right now, like some kids would look at that and say it's 11, but it's not 11 yet. It's still like 10:56, going on 10:57.
So we're still in the
So
10
like
o'clock hour.
that hour hand when it's in between, like what does that mean? And how the hour hand gets closer to the next hour as the minute hand goes around. Like that location is problematic.
Correct. Grace?
I think the fact that it's in a circle too, like every number line has always been like straight, so like the fact that they put numbers in a circle confuses.
Yeah, we're used to things being straight, like a ruler, for example. Yes?
The big hand and the small hand and also the red.
The second hand?
Yeah, so I'm a race.
Just mixing of the hands, okay? And by the way, I remember, it wasn't until I was an adult that red second hand, when I was a kid, I remember thinking, I wasn't associating with seconds. For some reason, I was keeping it separate in my mind. I was associating the word second with first, second, third. And so I'd say, okay, well the hour hand's the first hand, the minute hand then would be the second one, because that's the second one you learned, and then that one should be the third hand. So I could never understand that until I was an adult. So, I got all through school and everything, I never really thought about it again until I started to do something like this class here, and then it's like, oh, that's why that's called the second hand. It never occurred to me. Okay, any other ideas? Jim?
I actually think it's funny that even kids don't, not just kids don't know how to read them, because there was a girl when I was working at a pizza shop, she's like 30, she's like, what time is it? And I'm like, you don't know how to read that? She's like, no, I don't know how to read that. And like, it takes her a minute, she got it, but I was like mind blown that she couldn't tell time on one of those clocks, and she was like way older than I was. So
Yeah.
I guess it's not just kids that it can be confusing to, some adults that can be confused.
Yeah, some adults never do learn. Remember, I had someone here last semester that didn't know how to read the clock, and that happens a lot. I do get students in here that don't know how to read the clock. And then there's some that will, after 5th or 6th grade, I think one had a son or daughter that couldn't read the clock. They were in 5th or 6th grade. Okay, here are some of the things that I've listed or I've come across, and they're going to mimic a lot of what you have just said. Numbers 1 to 12 indicate hours, but you have to multiply by 5 or skip count to get minutes. So again, you were talking about the scale. Those numbers mean two different things. Depends which hand is pointing at it. We call these things hands. They don't look like hands, they're like sticks. Okay? The long hand reads the minutes, the short hand reads the hours. So I think, Tony, you were getting to that. You get those things mixed up. Hour hand must be in a range, not necessarily closest to a number. You were just saying that, Lauren, like right now, actually still right now, the hour hand is in the 10 o'clock range, even though it's closest to the 11. But we would say, like 11:59 or 10:59 or 11 o'clock, we aren't so interested in a range for the minute hand. It's pointing right at where it should be, or the range is incredibly small. Okay? So most students, like Lauren, like you had said in our first learnings, they would say, well, the big hand is close to the 11, so it must be 11. It must be 11:59. Okay? Let's see. Want to read the large hand first, but the minute hand is actually bigger and stands out more. We tend to look at things that are bigger first and then go get smaller from there. Let's see. Minutes begin over. Okay? And they begin at 0. So 11 o'clock's at 00. Hours never start at 0. So the starting point is different for both. Also, the minutes, they go around once and they start all over again. Okay? For the hours, though, it depends. Like in 12 hours, the clock's going to look like that too, but it's a very different time of day. Okay? So in one day, that thing is going around twice the hour hand. Okay? Which is why we use the AM and PM. Let's see. 0 is very unfamiliar to students. You're going to hear me talk about 0 throughout this semester. 0 is a problem. It's always a problem when you're adding or even introducing it, because when you think about it, when you're first introducing numbers to students, they have things like 3 blocks, 5 blocks, 8 blocks. You don't usually talk about 0 until later. Okay? Why would you have something that represents nothing? Why would you need to represent nothing? That makes sense? At least that's in their head. They're thinking these numbers represent these blocks. Well, why would you need anything that didn't represent anything? Just say there's nothing there. Well, we use the 0 here. And we're using it, and kindergartners aren't familiar with the 0. 60 minutes in an hour, but we use the base 10 system. You had said that. Okay, and I remember I got an elapsed time, by the way, is how much time has gone on. Like if I give you one time, like 2:45, and I give you 3:15, how much time has elapsed? Okay, and I do remember making that mistake, thinking that, okay, well, I think like 2.5 hours had gone by or something like that. And I remember thinking, hey, 2 hours, that's 200. And then I started counting the minutes. Okay, so I was thinking base 10. Terminology, we talked about that. It's 10 minutes till 11 o'clock, or 10:50, a quarter after 9, a quarter till 5, a half after, okay? Don't match up with money, and that's the first thing the students really associate with quarters and halves. Yes?
So what grade do you bring that into that? Because it does make sense, because if you break it into four quarters equal $1, there's 4 quarters in this clock. So what grade level do you bring that half past and stuff like that into?
Well, I mean, you can see from the standards, it's telling you where it has to be. So if you look at the halves, I think that's in, what's it, second grade? Oh, no, it's first grade. First grade is half hours, okay? How could I get the students, now let's just kind of jump forward here, because let's jump into first grade. The students are already able to at least read the clock somewhat, which we're going to get to that here in the class here, how to actually get them there. How would I get them to think of it as like a half?
Pizza, cutting and pounds and stuff like that.
Using something physical or using some kind of picture, okay? So I could have them take something like this. I could say, cut it in half, either physically cut in half or color half of it. How many minutes are in that half? And the same with a quarter, okay? Now, what I want to do too is, since you never want to ignore these possible areas of conflict, you want to hit them head on. And the one we just talked about was with money. Okay, so you don't want to say, oh good, they're saying 30 minutes, I got them now. You know, I'm not going to say anything about a $50, for example, or a quarter of $1, or anything like that right now. They're doing the right thing. Well, you're really hurting yourself. What you want to do is you want to get that head on. You might say, where are we seeing, let's just go with quarters, because that's more familiar than $50. So let's say they found the quarter, it's a quarter of a clock, it's 15 minutes is in a quarter, and now we learned about the quarter, or they already know it's 25 cents. You want to talk about that head on. You might say, well, wait a minute, isn't the quarter for a dollar? How much is that? 25. Well, how might you keep those things separate? So you want to get them to think about them and figure out their own way of solving that situation. You don't want to just give it to them. Because you might say, remember it's this, and then it's like this. Anytime they can solve their own problems, they'll find the best way to do it. Does that make sense? I mean, you could definitely share ideas if you want, okay? But you want to hit it head on. You don't want to say, okay, good, then later they're going to say a quarter is worth 15 cents. You know, they'll start doing things like that too. Okay? So how are they the same? Well, a quarter is 1/4 of $1. Okay? And 15 minutes is 1/4 of an hour. So you can relate it to fractions, to parts. Okay? In other words, again, we're looking at the concept of what that word quarter means. Okay? If they can figure that out, okay, then they might make a mistake, but if someone raises their hand and say, it's 11, how was I going to say this? Oh, the quarter in my hand is worth 15 cents. You might say to them, okay, what does a quarter really mean in terms of $1? Then they can start to say, there's 4 of them in $1. Say, okay, so if you had 4 of these 15 cents, what would you have? 15, 30, 45, 60. Okay, oh no, that's not quite $1, is it? So think about that. Now they start, again, you're getting back to the concept. That's why the concept is very, very important. Okay? Okay, so we saw, what were some of the issues going on with especially the bottom, reading that analog clock? What were the students doing? Think of these mistakes. He shows 2:45, and one says 9:15. What do you think they're saying 9:15? Yes?
Well, the minute hand will be printing at the 9, and then maybe, like, because it's getting closer to the next hour, getting closer to the 15-minute mark, the hour hands are thinking.
Yeah, so the hour so they're mixing up, first off, the two hands. And again, remember, they're more attracted to the larger hand first. And then they're missing the scale too, at least a little bit. Okay? Because they did convert that to 15. Okay, what about a quarter to 2, or a quarter after none? They're just mixing up the hands. Okay? A quarter to 2. They got the quarter part right. Okay, and they know what hour they're in. So they got the correct hour, they're just mixing up, these terms and applying them, in the wrong way. Okay? All right, so we're just gonna leave that here. Let's see right now. How about if we get back at 11:15, and then we're going to start seeing how to teach this in a meaningful way for students. Okay?